In today's lesson, we'll be looking at geometric sequence, series, or progression. So what is a geometric series? It's one where each term is a particular multiple of the previous term. So say for example, if you have the terms 2, 4, 8, 16, you can see that each of these numbers can be gained by multiplying by 2. And so each of these are multiples of 2, okay? This number here is what we call the common ratio, and that's denoted by R. So, if a series is geometric, then T3 over T2 is T2 over T1, which is R, and so forth. So, in the example I gave you just then, if you have term 3, which is number 8, divided by term 2, which is number 4, then that will give you 2, that's that. But if you also do term 2, which is 4, over term 1, which is 2, that's also 2. Okay, so the ratio is going to be 2. So, in generally speaking, what happens is the ratio is the term divided by its previous term on the left. So, in example 1, find the common ratio in the GP. 8, 4, 2, 1. Well, if I get T2, which is the second term, divided by the first term, 4 divided by 8 is going to equal half. So our ratio in this case is half. To get to one number to another, we just multiply by half. So, example 2. Determine whether the series 4, negative 16 plus 64 is geometric. So let's get term 2 divided by term 1. That's simply negative 16 divided by the number 4. That's negative 4. Now, if I then get term 3 divided by term 2, I get positive 64 divided by negative 16, and that is still negative 4. So therefore, the series is geometric only because these two ratios are the same. Okay, so we can say the series is geometric. Right, moving on. Question 1. Find the common ratio in the GP. So remember to find the ratio. We get one of the terms divided by the previous term. So I'll get a negative quarter divided by 3/8. So negative quarter divided by 3/8. Now you should know that that's the same thing as negative quarter times 8 over 3. And so these two numbers can simplify. That will give you 2 over there. So negative 2/3 is your ratio. Moving on. Write down the first 5 terms of a geometric series with first term 3 and common ratio 2. So we start with the number 3, but because the ratio is 2, we're going to multiply this by 2 and repeatedly do that to get the next numbers until we get the first 5 numbers. So multiplying by 2 again gives us 12, 24, and 48. Question 3. Find the geometric series with first term 32 and common ratio negative half. So we'll start off with the number 32, multiply it by negative half, and that will give us negative 16. Multiply by negative half again, and that will be 8. Multiply by negative half again, it will be negative 4, then 2, and so forth. Okay? But because it's a series that they want you to do, I apologize if you wrote this already, they just want you to write down a sign in between them. So there's 32 minus 16, plus 8 minus 4, and then plus 2, and so on. Question 4. Determine whether the series that is geometric. Well, in order to do that, you need T2 over T1. So second term is negative 7 over first term, which is 7, is going to equal negative 1. And we have to prove that it's equal to term 3 divided by term 2's result. So term 3's result is positive 7, divided by term 2's result, which is negative 7, and that will give you negative 1. So since the numbers here, the ratios are the same, we can say the series is geometric. Okay, right, so the series 1 plus 2 plus 6 plus 24 plus 120 plus whatever is geometric. True or false? Okay, so we're going to do the same thing again. So we get term 2 over term 1. We find the result of that first. So that will be 2 over 1, which is 2. And then term 3 over term 2 would equal to 6 over 2, which is 3. And you can tell that these two are not the same. So that means the series is not geometric. Right. Question 6. Find the next 3 terms of the series that. Okay. So let's find the ratio. The ratio is term 2 minus term 1. So if we get 16 over 27 divided by 32 over 81, let's just say I did that on my calculator. 16 over 27 divided by 32 over 81. That will give us 3 over 2. So if I want to find the next 3 terms of the series, I would have term 4 being 8 over 9 times by the ratio, which is 3 over 2. So 8 over 9 times 3 over 2 is going to be 4 over 3. Okay. The 5th term will be that 4th term, which is 4 over 3. And again, we'll multiply this by 3 over 2. And that's 2. And then term 6 would also be that same term from before, so term 5 times the ratio, which is 3 over 2. And that would be 3. Okay, so next 3 terms would be 4 over 3, 2, and then 3. Question 7. 8, x, and 50 are the first 3 terms of a geometric series. Find the value of x. So if they are part of a geometric series, then the ratios of the second to the first and third to the second are the same. So that means t2 over t1 is equal to t3 over t2. So we'll get the second term of x over the first term, which is 8. That's equal to term 3, which is 50, over term 2, which is x. And now we can just cross multiply, really. So if we cross multiply that, then x squared will give us 8 times 50, which is 400. And squaring both sides gives us the number 20. Okay? But the thing is, we can write a plus minus sign here because when you square root from a line that says x squared equals 400, you have to write that. And that makes sense because let's just say if you have the first 3 terms being 8, 20, then 50, and the ratio in this case, let me just double check, is 2.5. Okay, that makes sense. Okay, you can actually check it, and if you get 8 times 2.5, you get 20, times 2.5, you get 50. But if you had 8, negative 20, and 50, that's also possible, because you can multiply by negative 2.5, and that will give you those 2 numbers. Okay, so both answers of x are okay. Right, moving on. The nth term of a geometric progression. So in a geometric progression, the terms t1, t2, t3, they have to be multiples of each other by a ratio of r. Okay, so we've established that when we start with term 1, okay, and in AP's arithmetic progressions, we usually denote the first term as a, and to get from the first term to the second term, all we've got to do is multiply by r every single time until we get to the end. So you'll notice that t2 is ar, t3 is ar squared, t4 is ar cubed, and so forth. But I want you to have a nice look at the term number and the power. That power is always 1 less than the term number. Okay? So if the term number is n, then the power of the r would be n minus 1. So in generally speaking, Tn would equal to the first term times the ratio times to the power of n minus 1. Right. In example 1, find term 7 of a few numbers in this sequence. So this is already a geometric sequence. You can see that it's dividing by 2 every single time, or multiplying by half. So Tn equals to a r to the power of n minus 1. T7, which is the 7th term, is the first term, which is a, or 6 in this case. 6 times of the ratio of half. Now, up to you whether you want to write half or 0.5. I'll just write 0.5, just easy to type in my calculator. Then I'll have the power of 7 minus 1, which is 6. Okay? And that should give me the answer, 3 out of 32. Example 2. Find the number of terms in the following GP. Right, so this means we want to find out what is the value of n. Okay? So in this GP, we can see that there's the first term. We can also see what the ratio is, which is 3, because 9 times 3 gives you 27. We also have the last term. And this last term, as you know from before, in the AP questions, this is what you call Tn, the last term. Okay? So n would represent the term number. So Tn equals to AR to the power of n minus 1. We replace Tn by 2187. And we write this equal to A, which is 9, times the ratio, which is in this case 3, to the power of n minus 1. Okay? So what I can do here is I can divide both sides by the number 9. And if I divide both sides by 9, or 2187 divided by 9 should give us 243. And that should equal to 3 to the power of n minus 1. Now, I can choose to log both sides. Okay? I can log 243, and that equals to log of 3 to the power of n minus 1. And if I bring the n minus 1 down using log rules, well then, to get n minus 1, I'll have to divide both sides by log 3. Okay? So dividing that over, now let's check. Log of 243 divided by log 3 will be the number 5, exactly. 5 is equal to n minus 1, which leaves us our final step to do, which is to add 1 to both sides. So therefore, n would equal to the 6th term. So the 6th term here is 2187. Example 3. Find an expression for the nth term in the series 9, 27, 81 to 43. So, basically what it's asking for is Tn in terms of n. Okay? So, we do have our first term of 9, and to get from one term to another, the ratio would equal to 3. Okay, you can simply get that by dividing 27 by 9, or 81 by 27. So, Tn is AR to the power of n minus 1. And because we don't know n, we leave it as it is. Our first term is a number 9, so I'll replace a by 9. The ratio in this case is number 3. And we're putting this to the power of n minus 1. But if we're going to simplify this expression, well, 9 is the same thing as 3 squared, times by 3 to the power of n minus 1. And now we've got two bases which are the same. So that means if we multiply the two terms, we have to add the powers. So we'll get 3 to the power of n plus 1 instead. And that's our term formula, simplified. Alright, next in exercise 4.2, question 1. Find the 12th term of the geometric series with first term 2 and common ratio 3. Okay, so Tn is AR to the power of n minus 1. So we'll have T12 being A, which is number 2, times R, which is number 3, to the power of n minus 1, which is 12 minus 1. So you do 2 times 3 to the power of 11. And T12 would equal to 3 54294. Question 2. Find corrected two decimal places the 60th term of the series. Alright. So, Tn is AR to the power of n minus 1. T60 is 1. So that's our first value, 1. Now the ratio would be 1.2 divided by 1. So that's just 1.2. So we do 1 times 1.2 to the power of 60 minus 1. Okay, so I'll get 1.2 to the power 59 basically. And that should equal to approximately 46956.26. So two decimal places. Question 3. Find the number of terms in the series. Right. So in this case, we're trying to find out what the value of n is. Okay? So Tn is AR to the power of n minus 1. Tn is going to be the number 2187 at the very end. So 2187 there. A in this case is 128. But the ratio here is going to be 192 divided by 128. So let's see what that is. 1.5. So we'll have times 1.5 here in this instance. Then to the power of n minus 1. We'll divide the 128 over to the other side. So that 2187 divided by 128 is going to give us, it doesn't actually give us a nice number. Let me just double check that. Yeah, I've done nothing wrong. So 2187, 128 is 1.5 to the power of n minus 1. Alright, I'll just continue here. So if I log both sides, log of 2187 over 128 is equal to log of 1.5 to the power of n minus 1. Now, similar to before, we're going to place the n minus 1 down the front, log 1.5. I'll divide the log of 1.5 over. That goes away. So now if I do log of that fraction divided by log of 1.5, it gives me 7. So 7 is equal to n minus 1. So if I put 1 to the other side, I'll get number 8. Okay. Now, number 4. Is this big number a term of the series? Okay. So, I'll need to find out my term formula, and that's 2, because my first value is 2. My ratio in this case is 8 divided by 2, which is 4. So I'll have 2 times 4 to the power of n minus 1. And then you repeat the same thing. Okay? So you put this into Tn. Okay? And then you repeat the same steps as before. Okay? Eventually, you do get an n value that should be a whole number. Okay? So let's just divide that number by 2. So 3355432 divided by 2. That's 16777,216 equal to 4 to the power of n minus 1. And log both sides. And just put the n minus 1 down whilst you're at it. Divide the log of 16777,216 divided by log 4, and that would equal 12. So 12 is equal to n minus 1. So n equals 13. And because this is a whole number, we can say, therefore, it is a term of the series. And I mean, if it wasn't, then it wouldn't be a term of the series. There we go. Question 5. Find the common ratio if the first term of a geometric series is 25 and the fifth term is 15,625. So in this case, we've got A as 25. You've got the fifth term, T5, equals to 15625. Now the thing is, I'm going to rewrite this a bit better. Our first term is 25, right? So using the formula, Tn equals AR to the power n minus 1. A in this case is already 25. The ratio in this case we don't know, and that's the power of n minus 1. Oh, but we know that n is 5, so n minus 1 will be 4. So that's basically our formula there for Tn. And supposedly it's equal to this number here. So we can divide both sides by 25. So 15625 divided by 25 gives you 625. And if we do the fourth root of that, then we get 5. Okay, that's the ratio. However, because, again, the ratios are allowed to be positive and negative, you can get the negative version since we're doing the even root of some number. Okay, so the fourth root of a number. So make sure you write that plus minus 5. Next. Just like how we did in AP, we can have questions that involve simultaneous equations, but this time involving a GP. Okay? Last time I think we added we added or maybe subtracted 2 equations. This time we're not going to do that, and I'll show you how. So in example 1, in a certain geometric progression, T3 is 8, T6 is negative 1. Find T8. So our formula is AR to the power n minus 1. So T3 being 8 means, in terms of the formula, it will be AR squared. Okay, and that will be equal to 8. T6, however, would equal to AR to the power 5, and that would equal to negative 1. So now that we've got that, I'll call this equation 1 and 2. Equation 2 divided by equation 1 will be a nice thing to do, because this has a higher power of r than this. So if I now get AR to the power 5 over AR squared, okay, let me show you what I mean by that. I'll get AR to the power 5 over AR squared. That will equal to negative 1 over 8. And so you can see that the a's cancel out. The r to the power 5 divided by r squared would give you r to the power 3 equals to negative 1 over 8. And we simply do the cube root of both sides to obtain r equals to negative half. Okay? Now we're not done yet. We just found out what's r. We need to find out what's a. Okay, we don't know our first term at all. So we'll say sub into, let's just say the first equation. So sub into equation 1, which is this guy. So I'll get now a times negative half squared equals 8. Same thing as a times a quarter equals 8. And multiplying both sides by 4 will give us the 32. So, therefore, our term formula now, if you just put that a value back and the r value back in there, would be a as 32 times r, which is negative half, or negative 0.5, to the power of n minus 1. We can now successfully obtain the 8th term by replacing the n by 8, and this time we'll write negative 0.5. It's easy to put my calculator away. Okay. So 32 times negative 0.5 to the power of 7 would be negative a quarter. And that's it for today.